Okay, welcome back to S76. So tonight we actually dive into iOS programming, building on the material that you dove into with Rob last week. And what was that language that we spent the latter half of last week on? Objective-C, exactly. So let's see if we can't take a whirlwind tour of some of those topics and see if this will lend itself to recognizing some of the same constructs you saw last week, albeit in a different context, namely GUI programming today. So here was a canonical program, main.m. .m. That was probably a new file extension for some folks. What's the .m referring to? So methods, typically. So methods are where you actually implement your functions or your methods, and this is in contrast with the .h files. And a .h file in Objective-C contained what kind of things by contrast? So the interface, or the sort of the information that describes what the code is that you're about to implement. And this is an example that we'll see pretty much in every iOS application that we make, certainly ones that we make by starting from some of Apple's templates. And it is, I cannot think of a single instance for the next 4 weeks where you should ever actually touch this file. So you can take comfort in the fact that the way you get it is the way it should remain, but it actually is the file that kickstarts a lot of the magic that then proceeds to happen. And we'll start giving you a tour of that today. So let's work through this line by line as representative of some of the syntax we'll continue to see, even though it won't be in this particular file. So hash import, what does that do for us? First line in a file like this. Yeah. Yeah, it imports the library, specifically the library that's called the foundation library, which for Objective-C is all the basic stuff that you get with Objective-C, things like arrays and other types of objects, sort of like Java's collection classes and the like, so, or things you might get in C++'s standard library. So a lot of functionality right out of the box, and a hashtag import means that those method declarations will be automatically loaded into this file, so you can just start using them, even though someone else implemented those functions and those classes. So int main just means that this function returns an int. For our purposes, that'll pretty much be inconsequential, but this is one of the means by which programs can signal whether they were successful or not. If a program like main returns 0, that means all is well. If it returns anything other than 0, what does that typically signify? All is not well, and there can be almost an infinite number of things that could go wrong, and that's why we use 0 for good and a non-zero value for anything else. argc and argv typically refer to command line arguments, things you would actually provide to a program by typing commands at a keyboard. That's not going to be applicable for our iOS programming. And then inside here, we see some syntax that's new to Objective-C. Most everything else we've seen thus far exists in C or in a form similar to C. At auto release pool refers to memory management. And we'll come back to this over time, but in a recent version of iOS, a whole bunch of useful functionality was introduced that essentially means that we can start thinking about memory a lot less. And I'll point out here and there exactly where there is interesting memory management going on, but know that 2 years ago, had you taken this class, your lives would have been much more challenging when it comes to implementing some of the stuff we'll dive into today. But Apple has lowered the bar to getting into Objective-C programming, in part by hiding some of the complexity of memory management. NSLog is just a function like printf that will print a formatted string, but to a specific place, a standard logging mechanism that we'll actually see in Xcode, which recall is the IDE we'll use to program in Objective-C. Return 0 means that we're assuming all is going to go well, and we will pretty much never see this function again. Yes, questions? Good question. Should you start every program with auto release pool? Short answer, yes, but Xcode will actually write this code for you. So we'll actually see in a little bit a function quite like this, but with one additional line that kicks off the magic that is the SDK that comes with Xcode for iOS programming. So you can literally just take what's given to you out of the box. All right, so here's some syntax. And just to be clear, I've gone into Rob's slides and I've deleted some of the comments so that we can put them back to make sure that we're all on the same page before we forge ahead. So this is what you might see in a .h file or a header file. You said a moment ago that this is where declarations of methods and classes might go, but not the actual implementations. I have 2 comment symbols here. What goes where that first comment symbol is specifically? What do you put inside of an @interface declaration? So instance variables. And what's the definition of an instance variable, to recap? Okay, almost a circular definition here. What's an instance? Instance of what?
An instance of a class.
An instance of a class, otherwise known as an object. So an instance is just an object, an instantiation of a particular class. An instance variable is a piece of data, maybe it's 8 bits, maybe it's 32 bits, maybe it's even bigger, that's specifically associated with the specific object that was created using some class as its blueprint, so to speak. So this is where our instance variables might go. And how about outside of the curly braces, but before the @end symbol? What goes where those second comment marks are? Class methods, sure. So we can declare class methods there, not implement them, but declare them, which means, hey, compiler, here is the name and the signature, all of the arguments for a method I'm going to implement elsewhere, elsewhere being the .m file. And what else besides class methods can go where that second comment symbol is? Instance methods. So instance methods are sort of the opposite of class methods in the sense that a class method can be called even before you instantiate an object. So if you just know a class's name, you've never actually used it as the blueprint for creating an object, you can call a class method on that class without an object existing. And this is hugely useful because you saw one, at least last week, that allows us to avoid what would otherwise be a chicken and the egg problem. If we didn't have class methods, we could never allocate or alloc an object of a particular class, and that was the plus alloc that you might recall from last week, and we'll continue to see tonight. An instance method, by contrast, is one that you call on an object or a particular instance of a class. Exactly. So we'll start seeing a lot of this, and we'll start writing our own classes in this way. But there's one last syntactic detail that's worth recapping here. The colon space ns object means what with respect to foo? It inherits from the ns object class. And most classes that we would ever write, most classes that you'll use in the SDK that Apple provides, do at some point descend from ns object, even though there's typically even more layers than just one between you and that root class. So we'll see more of that in the time to come. So instance variables and declarations of methods. And these slides are online if you'd like to download them as usual. .m files contain implementations. And this is one of the sort of unfortunate design decisions of Objective-C that you may recall last week. Even though you do have balanced curly braces in a lot of places, you also have wonderfully asymmetric ways of starting and ending a sentence, so to speak. You have @implementation and then @end, which is the opposite. But we saw this a moment ago. What goes where that comment symbol is? The definitions or the implementations of those methods. So you typically begin by copying and pasting the declaration or the signature of your methods from the .h file, but then you proceed to open a curly brace, implement it, and then close a curly brace. And we'll certainly do that tonight as well. So there go our definitions of methods. All right, so now a bit more syntax. Messages we looked at last week. And this is a valid line of code that assumes that a class called student already exists and has been declared and defined elsewhere. It could someone, in somewhat technical but roughly layman's terms, explain what the two halves of this line of code are doing. Let's start with the side on the left of the equal sign. What's going on with those symbols, student, star, student? Yeah? Creating an object with a pointer called student. Close, but we're not doing as much as you just proposed that we're doing. We're doing a little less. Yeah?
So create an object named the student that belongs to the class of the big student.
Again, I'm going to find fault with your use of create an object. Yeah?
Create a pointer to where the object will live.
Exactly. Perfect. So create a pointer, which is just storage for an address, and the name of that pointer is apparently going to be student in lowercase, and that pointer is going to point to, in other words, store the address of an object of type student, capital S. So all that is happening on the left-hand side of that screen is that we're allocating probably 64 bits or 8 bytes to store the address of what will be a student object. But at this point in the story, only looking at the left-hand side of that line of code, none of the object instantiation has happened yet. All we've done is created an empty placeholder for what will be the address of some student object. So now we can rewind and go with the right-hand side. What's happening on the right-hand side of the line of code? Exactly. On the right-hand side of the code, we are allocating, in other words, instantiating an object of type student. And what that syntax with the square brackets is presumably doing is somehow returning what to the left-hand side for assignment?